When we talk about our genetic evaluations and EPDs, breeding values, things along those lines, currently in genetic evaluation, we kind of just assume it's the same no matter where you're at. That sire is going to have the same potential to pass on to his offspring, whether he's in Florida or whether he's in Montana. And now many that's usually just for simplicity's sake, just because otherwise the modeling and the interpretation just gets way, way out of hand for the most part. And it's a big leap to go from a singular value to many, many values, many, many EPDs just for the same exact animal and the same trait.
Welcome to the Beef Podcast. I'm one of your hosts, Brandy Buzzard, and it's my pleasure to bring you the trending issues and topics with the best and brightest minds in the beef industry. Today, we are joined by Will Shaffer. Will earned his master's degree in genetics from Kansas State University and is currently a PhD candidate in genetics at K-State. I'm looking forward to learning a lot about genetics today, and I'm always thrilled to have a fellow Wildcat on the show. So welcome to the show, Will. We're happy to have you. How are you today?
Thank you for the kind introduction. I'm doing pretty good. Having a great day. It's a nice day here in Manhattan, Kansas. I do have to say, though, I'm a little partial to my Pokes as well. So go Pokes. But I'll root for the Wildcats as long as they're not. I'll root for the Wildcats as long as they're not playing each other.
That's not how I wanted this episode to start out.
Hey, I also represent my Kansas State Wildcats as well.
You do have the purple on there, and when I was reading, you had sent in your it's not pre-work, but some the information about you, and I was reading your LinkedIn. I saw that you went to Oklahoma State, and I was just choosing to gloss over that and just talk about the K-State part. But you wanted to bring it up, so I guess we're there. I have a brother-in-law, and one of my sisters, brother-in-law, and one of my sisters-in-law went to school at Oklahoma State, so I have like a small tie to the Orange School from the South. So anyway, well, we're happy to have you on here today, and I'm looking forward to talking to you. Just to start off with, I know that you have a long career and background and accomplishments and things like that go many years back that didn't just start, in the last 3 to 4 years. So just to start off with, can you tell us about how you got involved in animal science and the beef industry and your career path so far? Like I said, I know there's a lot more below the surface than what I just briefly read.
Yeah, I'd say really to answer that, to go all the way pretty much back to back on the family farm back in high school even. And I think my interest in genetics as it starts today actually began on the farm when we were making selection decisions, culling cows, deciding what matings to make, what sires to use for artificial insemination. And I was always wondering, it's like, well, how do we actually make genetic progress? How fast is it? Like, how do you actually go about that and do that effectively? And that's what actually led me into Oklahoma State, where I was animal science and biochemistry and molecular biology dual major there. Ooh. And I did a lot of molecular genetics research while I was there with Dr. Rolf and Dr. De Silva, actually both, for anybody who might know them. And had a great time at Oklahoma State. I love Oklahoma State. I love Manhattan. They're very similar places, very similar type of feeling, if you will, for schools. And I recommend both of them quite a bit to everybody. I've had a great time at both, in all honesty. But at Oklahoma State, I did a lot of undergraduate research as well on the molecular side of genetics. But I really realized that when it comes to making genetic progress, what I was really more interested in was topics like animal breeding. And that's what led me to want to pursue more of a quantitative type of study for my graduate education. And that was kind of a bit of a 180 for me because in undergrad I was used to physiology, molecular biology, biochemistry, very still great topics and very hard things. Don't get me wrong, there's a lot of late nights in the library. Mm-hmm. But I hadn't really focused too much on the mathematical background. So that was a little interesting, going straight from pure biology, more or less, pure molecular biology, to statistics and calculus and all these other things I really haven't had a whole lot of coursework in. So it's taken me quite a number of years to really develop those skill sets. But I first went to the University of Missouri and I was a bioinformatics PhD there for a couple of years. But that didn't end up being really the right fit for me. I felt like Columbia wasn't quite, my work there and sort of the program I was in wasn't quite the right fit. So I ended up transferring to Kansas State, actually, and start here in 2019 in the fall, just in time for that pandemic, a few months later in spring. Yeah. So that was, my graduate career has been a little topsy-turvy. It's not been the most smooth thing in the world. But here I was immediately on the genetics track, but I was in the quantitative genetics realm. I was
Hmm.
taking a lot of statistics based courses. I did some calculus self teaching, just enough to get through some of those math, just to get through a little bit of
Oh.
math stats. Not very much. It's more so how do I do the same same little derivative over and over, just so I can get through the class. I was more interested in understanding the concepts more than anything,
Hmm.
just understanding why calculus is important rather than be able to do all the algebra myself. So for those of you out there who may not like math or may not be too math inclined, uh, not going to say you won't ever have to do math, but you can focus a little bit more on the conceptual side of things and how to implement it and how to understand what it's doing in the models you're running if you want to avoid some of the more heavy theoretical stuff. That's what I do at least. So I've been here now the last 5 years, and I've worked my master's degree, and I'm currently working to wrap up my PhD currently.
A healthy digestive tract is a prerequisite for overall calf health and performance. It affects the absorption and utilization of nutrients and influences the calf's immune system. Digesterom Calf from DSM Firmenich is a phytogenic product that can help benefit gut bacteria to improve gut functionality, immunity, and performance. Take care of your calves with Digesterom Calf. Visit dsm.com/digesterom to learn more.
So the amount of math that you just talked about with calculus and algebra and statistics, and I'm just having like flashbacks of PTSD of not remembering during, like, in my statistics class when I was in grad school, like you had to figure the standard deviation, and I couldn't remember
Mm-hmm.
how to do it the easy way, and so I ended up having like doing it the long way just so I could get the work done. And I never want to take another math class in my life ever. Just ever. That was the least favorite part of my grad school. And then here you are, like fully embedded in it, entrenched in math and things. And so, um, there are people who use that every day. And so you definitely are in that realm. I tell people that I cannot tell you what like some hard algebraic equation, but I can tell you why in my line of work, which is communications, you don't need algebra. And I can write that in 500 words in that. So we all need different skills, but that is uh, that is a lot of math.
I am admittedly one of the oddballs that actually really enjoys statistics, but I will also admit that I had some pretty good professors when I came here who really focused more on the applied part of it. We had to go into the math quite a bit too and learn some of the black box part, if you will. But when you actually focus on the applied and what the implications for making different decisions are, it becomes a lot more interesting when you can actually use it and see what your decisions are actually doing.
I'm sure that definitely helps. I had one of my friends was in grad school with me. She was in animal nutrition, swine nutrition, and she was really good with stats and SAS for like running data. And I would just remember going over to her house and just like with my stack of papers, just like, please help me, please, I have to get this done. So it takes all kinds of people and education and things like that for animal science. And so I appreciate you willing to subject yourself to those things for the betterment of the beef industry, so that I do not have to do that. You spoke a little bit about how your passion, how you got started in genetics and like where that animal breeding that started on your farm. Like, are you from Oklahoma? I know you said you went to Oklahoma State, but are you from Oklahoma originally?
I am actually from Missouri, right around a place called Carthage, which is pretty close to the Joplin Springfield area for those that might know those places. And my family has raised registered Charolais cattle for,
Mhm.
gosh, I think since I was about 10 years old, so going on 20 years now, pretty much. We were kind of more of a commercial cow calf operation right before that, but now we do registered Charolais seed stock. Did the livestock showing myself for quite a number of years, up until really through most of undergrad, I would say, and still assisted my family, my sister, with that, even though I wasn't really showing myself at that point. And it's really, I think, only been the last couple of years we've kind of slowed down, not really done anything with the show side pretty much anymore. But I'm very familiar with that background. That's where I'm from, and it's kind of been interesting to see what I've learned and what I do now, and how producers make selection decisions and what happens in a show ring. It's been really interesting to see all the different sort of paradigms, if you will, for how things are practiced, and something I didn't really appreciate myself probably 10, 15 years ago.
Well, it's nice you've been able to like achieve your goals and grow in your career, but you're not, on the other side of the country doing that. I know how far Manhattan is from Carthage, and so I'm glad that you're able to go and get that family time and get back to the farm when you need it. And so that's great to hear that. Um, getting to like the meat of all this, and I don't mean to make that any pun intended or anything, but your PhD work is focused on genotype and environment interactions, which is something I had never heard of before speaking with you. And so I'm hoping that for those of us who are not well versed in genetics and that kind of genotype and environment interactions, would you be able to give us a breakdown of what that means?
Yeah, absolutely. So I did a lot of that. Most of that work was in my master's, and I'm hoping to do a little bit in my PhD if we have a little bit of time here. At least that's the big hope. I'm hoping to extend on what I did in my master's. But more when we talk about our genetic evaluations and EPDs, breeding values, things along those lines, currently in genetic evaluation, we kind of just assume it's the same no matter where you're at. That sire is going to have the same potential to pass on to his offspring, whether he's in Florida or whether he's in Montana. And now many producer, and that's usually just for simplicity's sake, just because otherwise the modeling and the interpretation just gets way, way out of hand for the most part. And it's a big leap to go from a singular value to many, many values, many, many EPDs just for the same exact animal and the same trait. But we as producers all know that a sire that works really well in the humid, hot South does not work well in the mountainous regions of Montana, for example, or
Yes.
Wyoming.
Right.
And that's where we're getting into this whole thing is a genotype by environment interactions, or I call it G by E for short,
Mm-hmm.
is that, hey, we know that your genetics or your breeding value predictions, your EPDs probably are going to be different depending on where you're at. And so then the questions we kind of need to answer is, A, what does that difference look like? How different is this? Are there animals who are really good in one singular environment? They might be really good in Florida, but not good in Montana. Can we identify animals that are really good and consistent across many different environments? And then what does that between environment predictability look like? Can we use information from Florida to make predictions in Montana, or is that going to be just wildly inaccurate? So that's sort of where my research is aligned. And I actually focused on a topic that I'll give the scientific term and I'll make it the easy term afterwards. I call it phenotypic stability.
Okay.
But all it is what I mentioned earlier, which is, can we select for individuals who can perform quite stably over many different environments, like have the same relative phenotypic performance?
So what did your like you said you did your master's research on that, so I'm assuming you wrote your thesis on it.
Mm-hmm.
What kind of outcomes did you discern from that research and from that, from your projects?
Yeah, absolutely. So our main sort of production trait of interest that we had access to was dry matter intake. I also used respiration rate as one of my other traits that I looked at as well, and that's kind of more of a side deal looking at for fun. Although we did find some interesting stuff from it that I'll get into in a minute. And then the environments I looked at were actually the temperature humidity index. So trying to relate dry matter intake genetic potential to the temperature humidity index, as well as water availability. And so this water availability, this is actually kind of funny. It's a little bit of a history deal here. This water availability, water restriction type study actually took place at Oklahoma State while I was an undergrad there, ironically.
Mm-hmm.
I actually ended up helping out a little bit of data collection during that whole process. So it's kind of come full circle. I've
cool.
I've helped with that. Now I'm working on grad school here, and I had no idea I'd be doing that at all up until 2019. It was quite the crazy ride. Ironically, it also started about the year I started undergrad, so it's kind of been part of my life ever since I started college in general.
It's been going for a long time, for a while then, yeah.
Yeah, so I think data collection did end in 2018, but as anybody knows, there's a lot of work you can do. There's a lot of work to do on the data after you finish collecting it. And there was so much data, there's probably enough data for dozens of students if they wanted to find a project out of it. So it can keep going for as long as we want it, pretty much. Now, it's kind of nice thing about that data says it was so encompassing that you really can do a lot of work with it. I'm actually still doing some work with that on my PhD with some microRNA stuff that we can talk about later. But getting back to sort of the G by E type stuff and when I did my master's, I was looking at dry matter intake and respiration rate and how they changed across the temperature humidity index, or how or across what we call water restriction, when we purposely limited how much water they could drink.
Mm-hmm.
And now it's just a fractional amount of like what they would normally drink if they weren't being restricted. Is how we define that. And for the temperature humidity index, that's probably the most telling. We did see clear decreases in performance as the temperature humidity index increased, and we only evaluate 70 THI, which would be roughly about your kind of thermal neutral edge of your thermal neutral comfortable zone, if you will. It's getting a little hot and humid, but not too bad yet.
Mm-hmm.
And then we analyzed that up from there. I think we reliably got up into the mid to high 80s, and that's Oklahoma weather. So just to
Mm-hmm.
kind of give you an idea of what mid to high 80s look like, that's your hot heat of the summer with a little bit of humidity thrown in there, pretty much.
Mm-hmm.
So that was kind of the range we worked with. So we were only really looking at heat stress rather than cold stress, if you will.
Right.
And dry matter intake did clearly suffer. That was pretty obvious from a population standpoint. And no one's probably surprised by that. Respiration rate also increased. Again, no one's surprised by that. Trying to
Right.
expel more body heat. From the genetic standpoint, we were looking at when we looked at dry matter intake, we tried to fit that line of best fit for each animal, if you will, and then try to look at that population alliance for all of our animals. So we took all those lines that we just drew for our animals. Can we make some inferences about that? And my goal was to evaluate whether we could select for that phenotypic stability or stable performance. So if you imagine, I wanted to take that decrease in dry matter intake and I wanted to make it flat. I wanted to make them
Right.
perform very stably. Unfortunately, what we kind of noticed there was if you wanted to select to make that line go flat, what you were actually doing was you weren't bringing the line up, you were just dragging that line down. So is what it really seemed like. Now, there was some variation there. You could over time select to improve both, where you get the line flat and also don't bring it down as much, you actually bring it up.
Uh-huh.
But that would be very difficult to do. The correlations don't really allow you to do that very quickly. So that'd be very difficult to do, but it is possible, just very slow. So what I learned from that is and this is pretty typical across most GBIE literature, is there is that trade-off between selection for overall sort of, if you will, performance, overall dry matter intake across all environments, or in the case of thermal neutrality at 70 THI, as well as trying to select for stable performance. So this really gets into what your goals for the operation are, which I know you're probably going to want to talk about here in a second, because that's probably the more practical approach to it. The second thing we looked at too was that inter-environmental predictability, like we talked about, and we did that by looking at the correlations for that genetic potential at 70 THI versus 85, for example. And we did it for all pairwise combinations. And when we looked at that too for the temperature humidity index, as the temperature humidity index values got really far apart, like 70 and 85 THI, those correlations were very, very low, close to zero. I think we got as low as 0.2 even. And what that really indicates to us, at least, is that that's not really letting us predict performance across very large differences in environments very well at all. And I think producers wouldn't be surprised by that. You can have a bull that does very well in Montana or in Florida, and then you try and go use it in Montana or vice versa, and you may not see that. And so and you probably won't see that same level of performance or be able to predict it very well across both. And so that's probably not unexpected.
It sounds like that I'm going to call it GBIE as well, because that is a much shorter way than me trying to stumble over genotype and environment interaction. So,
and for sure.
Yeah. So it sounds like is GBIE, are those interactions and that relationship, is that always important, or just in certain situations like what you're describing, like in heat, humidity, or is that kind of always important based on the different traits and the different, I guess what you're looking for in outcomes?
Yeah, that's an excellent question. I'm glad you asked it, actually, because it leads right into my other environmental variable I looked at, which was the water restriction piece. And it turns out not always. So we did see, and I'm going to call this decrease in performance as the environment changes, like gets more extreme. I'm going to say as the environment gets more extreme, like getting hot, for example, with the temperature humidity index. I'm going to call that environmental sensitivity. And so I'll refer to like the population environmental sensitivity, which is how, on average, what's happening. Of course, as it gets really hot, we expect feed intake to decrease, right?
Mm-hmm.
But that isn't what we call population level environmental sensitivity. And then you have the individual level sensitivity, which is those individual lines for each animal I talked about, looking how each individual animal is doing. With water restriction, we did see a little bit of environmental sensitivity there, and that feed intake would decrease as you decreased the amount of water they had access to. Again, I don't think anybody's probably too surprised by that. It's pretty expected.
Right.
Good indicator the model's at least not completely wrong, but good. But no one's surprised by that. But what we did see is that there wasn't a whole lot of variability in terms of individual level responses. So same kind of scenario where you have that trade-off between, do I try to make that line flat, and you drag that line down instead of trying to drag it up. So we still get that same trade-off between overall production versus what I call that phenotypic stability or stable performance. But what we were seeing is there wasn't a lot of variation around that environmental sensitivity or that degree of how slopey that line is, if you will. And so most animals that were performing best at zero water restriction happened to be performing still the best at high levels of water restriction. So there wasn't a lot of animals that were crisscrossing their lines in what we call re-ranking.
Okay.
So G by E actually wasn't very important in this case. There was environmental sensitivity, and we can select to reduce that to restrictions in water intake. But as far as that inner environmental predictability, if you will, an animal that performed the best at 0% water restriction still performed the best at 50% water restriction. Generally speaking, our correlations were generally about 0.8 or higher, even at the most extreme ends. Yeah, so very close to one.
Yeah.
Yeah, so in that case, G by E is really not all that important. So that kind of highlights another thing I have interest in the future is really, how do we find all these important environmental features that are actually important? How can we kind of distill them to something that's a little usable, right? I mean, you can do an evaluation for every environmental feature characteristic you want, but we're already talking about a line of EPDs now rather than a single value for a trait. Now try to do that for multiple environmental characteristics, and that's going to become very unwieldy very quickly. So that's kind of one thing I'm interested in the future, is how we can distill all those different characteristics in something that's a little more approachable. But yeah, good question. G by E doesn't always matter, but there can still be environmental sensitivity. We know as you decrease water intake, for example, the feed intake is going to decrease as well.
Go ahead.
As far as traits go, the other one we looked at was respiration rate, and respiration rate wasn't nearly as impacted, I would say, as dry matter intake, especially on the water piece. Although an interesting thing we did find, I will say, on the temperature humidity index of respiration rate, of course, respiration rate increased as the temperature increased. Again, no one's surprised there. But we found, and you would never practice selection for respiration rate directly, we were just exploring it just out of interest, but we found that if you selected for decreasing that respiration rate in really hot environments, so trying to bring that respiration rate down, right? If they're having a really high respiration rate,
right? We
found that actually increased respiration rate under thermal neutral environments.
Oh, okay.
Which was, and vice versa, if you try to decrease respiration rate when there wasn't heat stress, you'd increase it when there was.
Right. It's very interesting.
That didn't make sense initially. That's not at all what we expected.
Right.
But then we dug a little bit into the biology of it, and I think it makes a little more sense when you think about biologically. When you talk about heat and having to eliminate heat from the body, because that's what respiration is doing in cal. So that's what they're trying to do, is eliminate that body heat. You have two sources of that heat. You have the environmental grading, which is how hot is it outside, how well am I able to let heat escape. If it's really hot, the heat. It's like if you have cold. It's like if you are cold outside. If it's really hot, and you get hot, it's going to be very hard to cool down because the heat's not transferring that well when it's already hot. But there's also internal heat generation. That's just a byproduct of your natural biochemistry and metabolism there. As you just try to live, though, you're going to produce body heat in the natural biochemical reactions just to produce energy and put muscle on, whatever you might imagine. Or if you're just doing work to, again, build energy, you're going to lose some of that energy production as heat. And so respiration rate, we found, was actually kind of a proxy for the elimination, a proxy for metabolic heat generation. So when you think about that, if you're selecting to decrease respiration rate in heat stressed environments, what we found was you're actually selecting to decrease production, decrease that metabolic load. So you'd actually probably expect less. If we were to take into account correlations we've seen in other literature and traits, we'd probably expect your average daily gain would decrease if you tried to select for decreased respiration rate in heat stress conditions. But you would see the added benefit of that. You would see a slight added benefit of increasing average daily gain at thermal neutrality.
Okay.
So that's when you kind of get into that, oh, there's a little biological function there, and it makes a little more sense, even though it doesn't make sense initially.
Right. I mean, it's kind of like how, I mean, it seems that's how like what all research starts as, is like there's an issue here and it doesn't make sense, but if we dig into it further, it will make sense if we, look at the different factors and such. All right. Well, so how can producers take the outcomes of your research and improve or enhance the rate of genetic selection or genetic progress in their own herds?
Also, a very excellent question, and I have to first start off and give a little bit of a cautionary detail here. Is that unfortunately there's no one answer fits all, like most things in life. It's not going to be a black or white issue, of course, and I think most people are probably aware of that when it comes to genetic selection. Just what's best for one person isn't going to be best for everybody. And so I'll start with saying it depends, but I'm going to go into how it might depend a little bit. And the first one is really you have to determine who your clientele are. And I'm going to focus a little bit more on the seed stock here, but as a commercial producer, this could absolutely focus to you on the reverse end as well. On the seed stock part, if you're selling germplasm, but you're only really selling to people in your local vicinity, and let's say you're in a mountainous region, maybe you don't really care too much about selecting for stable performance across the temperature humidity index, right? That may not be really all that important to you. Probably doesn't get too hot in the mountains, I assume, at least not compared to Florida or Texas, for example.
Yeah.
In those cases, I would encourage something what I call local adaptation or local selection. That's where we hone in on that 70 THI piece, or maybe we even have to look at cold stress here a little bit instead, because the mountains do get colder. But
Right. Yeah.
we're going to pretend it's a nice, comfortable environment all times of the year for now, at least, just for a little simplicity's sake. And you might say, well, I really want to look at the results for 70 THI, or the edge of right before heat stress is beginning, or right where that threshold where it begins. And I really want to focus on that, the results there. I really want to focus on the EPDs there to practice selection, because the heat stress stuff doesn't matter to me and my clientele. We're not producing cattle in a region where that's going to matter. Now, maybe you might have to think about if your clientele are commercial producers that are shipping those weaned calves off to a feedlot somewhere, and there's some relationship there, though.
Yeah.
That's where it might get a little more tricky. And so it's really about understanding who your clientele are, in my opinion, about what's going to drive your decision making. Now, as a seed stock producer, on the other hand, maybe you sell semen, AI straws, all across the country, possibly even across the world. You might want to market a more consistent product, or maybe that's one of your goals, is to have a consistent product that no matter where people are at, they're going to say, I expected this level of performance. On average, that's what I'm actually achieving, or this level of increase in performance. And that might be a case where this concept of phenotypic stability comes into play, and utilizing the EPDs associated with, I'm going to say, remember we had that line. It's actually the slopiness of the line, if you will. We can actually generate an EPD for that. And you might want to focus on the slopiness of that line and how you can change that to be more consistent, to make that flat line, if you will. Even if you're dragging your performance down just a little bit, maybe that consistent product is worth it when it comes to a marketing, for example, as a seed stock producer selling semen across the country or world. And that's where I say what you're trying to accomplish really, or what you should do, really depends on what you're trying to accomplish and what your clientele are. But that is the beauty of these types of models, is they're not making nearly as many assumptions as we do in our current genetic evaluations. And it does give you that flexibility, albeit there's going to be, they are more difficult to make happen. And which environmental characteristics are important are, of course, difficult to determine right now. And there's also going to just be a lot more information in general than that just one simple number that we're used to seeing for average daily gain, for example.
Right.
That's why that really hasn't been implemented too much yet, is some of the technical challenges, of course, but also there'd be a lot of new education and extension that need to happen to streamline that to producers as well.
Well, and I think what you just really hit it on the head there at the beginning when you said, there's 1,000 different ways to raise cattle in the beef industry. And so an outcome from research potentially has 1,000 different, implications, right? Because everybody raises them differently, and particularly in different environments and geography. So I think you really kind of hit that right on the head there at the beginning. I know that you've been hinting at like some of these other researches that you've been excited to talk about. So I want to give you time to do that, because I know you're working on some special things in your PhD work. But so what research are you excited about outside of G by E now? And then, as you finish your PhD and you look towards, your more
Mhm.
long-term career. I guess I haven't even asked you what your goal is after you finish. You defend, or is it called defend? Yeah, defend your PhD and move on. Why don't you tell us that really quickly, what your goal is, and then we'll go in, and then you could go into the research, what you're looking forward to.
Yeah, I'm hoping to finish up here hopefully within 6 or so months. Maybe that'll flex a little bit depending on how things evolve and the writing process, of course. So, but
Hmm.
6 months is kind of the goal currently.
Oh,
As
good.
far as what comes after, I've got some ideas. I've definitely talked to the United States Naval Research Center about doing some research up there with
Oh, wow.
them. I've actually talked to some plant companies as well. They've just like maybe switching sides to doing plants, although I love animals. So I'm trying to stay in animals, of course, but I'll go wherever there's a job. I'll go wherever I get a job. That's gonna be the first thing.
There you go.
As far as aspirations, I'm pretty open. I think I'm abandoning, not abandoning, but at least for now, wanting to take a break from the academic setting and get a little more into industry.
Yeah.
Uh, and the United States Naval Research Center was kind of a weird mix of both. It's a mix of academic and industry, and since it's a government position there,
Yeah.
so it's a government research center. So it's a weird mix. But I'd have to say I'm pretty open so far. The cliche answer is I don't know yet.
That's okay. I am nearing 40 and I still don't know what I want to do when I grow up. So you're perfectly reasonable. And yeah, I'm sure to anyone listening, he is, what is it? Open to work. Is that what it is on LinkedIn? You can make that little
That
designation
little
on your
circle that
profile.
goes
Yeah,
around your
like open
profile.
to work. Will is open to work. So, well, that's
Let's say
exciting that
open to work.
there you go. That you're
29
still,
years old, going on 30, and I still don't know what I want to do, people. So if that's you too, if you're younger out there, it doesn't change.
that's right. We don't expect 18-year-olds to know what they have to do with the rest of their life because, again, we are almost 30 and almost 40, and we don't know. So, well,
Exactly.
that's great. Congratulations on being so close to finishing. Okay, and now let me now go. I would love to hear like what research you're excited about, that you're doing now or that is coming up soon.
Yeah, absolutely. One of the things I'm working on quite heavily right now in my PhD is male fertility with beef, particularly with beef on dairy. I am going to try and attempt to do beef on beef as well. We're kind of seeing if we have enough data right now. We're about to start digging into those analyses to see if we can get it to work pretty well. But definitely the beef on dairy side is what I'm looking at right now with beef sires on
Hmm.
dairy females. And I'm really excited about that research because I've got some really cool ideas for it. The first thing we're going to look at is a trait called sire conception rate, and that's kind of like your heifer pregnancy, if you will. But on the sire side is
Right.
what's the probability that sire is going to be able to inseminate and inseminate a female that leads to conception, more or less. What's that probability? Now, the difficulty we've had in the past with that, and why not many people have really focused on that, is that you don't really see a whole lot of genetic variation there, at least if we can capture with our models. And there's a few reasons for that. I think one of the more important reasons is we don't want, as producers, studs, semen collecting agencies, etc. We
Hmm.
really don't want that straw to not lead to a conception. That's not good for business, I think, for anybody. If you get too low conception rates, people won't want to do business with you.
Hmm.
So one thing I think at least one thing I think that happens, or should say probably does happen, is those straw dosages are probably calibrated in such a way that they're going to, even if a sire didn't collect well, they might concentrate the spermatozoa. That way, he has a higher concentrated straw that might lead to a higher conception rate. So we're kind of removing some of that natural variation just to achieve those higher conception rates. And that's been kind of one of the challenges we face. And so we're not entirely confident if we're going to see much because of some of that, what we call data censoring in that case, because we're not really allowing the sires who don't do well to fail because we're trying
Hmm.
to achieve higher conception rates. And so it's really hard to evaluate it when you have that happen.
Right.
But one of the other challenges I think that occurs with something like sire conception rate, and it's going to be very similar to heifer pregnancy. And I'll segue into heifer pregnancy because I think it's a little easier to visualize what I'm about to talk about here.
Right.
Because when you think about pregnancy process, and of course it takes two to tango, but I'm going to focus more on the female for a second.
Okay.
If that heifer doesn't ovulate or that cow doesn't ovulate, no pregnancy, right? There's no oocyte there available for fertilization. if that fertilized zygote doesn't implant to the uterus, no pregnancy. Multiply by zero outcome, no pregnancy.
Right.
If there's not enough placental attachments, maybe a placenta, and maybe you can get even deeper into biology and say placental binding proteins, etc. The cow's a
Mm-hmm.
little interesting with the caruncles, of course. It's a little different compared to like a smooth uterine lining, but
Mm-hmm.
not enough uterine attachments, multiply by zero, no pregnancy, right? So pregnancy, at least pregnancy outcome that we talk about when we talk about having pregnancy or sire conception rate, is this binary trait of zeros or ones, which are already kind of lacking a lot more information than something that's a number like a weaning weight, for example.
Mm-hmm.
So those tend to be more challenging just because of that nature of the data as is. But they're also really representative of a lot of things happening in the background that we would probably better to evaluate there if we had a better way of measuring them and collecting them reliably, like ovulation or
Mm-hmm.
placental binding or things along the sense. And reproductive physiologists, please don't crucify me there. I know I'm just trying to give some examples. Maybe progesterone concentration, for example. So
Yeah.
apologies, reproductive physiologists. I know I'm probably a little off the mark there, but
That's okay.
these things are all the underlying traits that really give rise to that pregnancy. We just don't have a great way to measure them inexpensively or without extensive amounts of labor, but they interact in a way that our models probably don't do a good job of actually capturing. That's why I think that's another reason why we see very little variability, genetic variability captured
Mm-hmm.
for things like heifer pregnancy and sire conception, right? And not to say they're not useful. You still can clearly make genetic progress with these traits, by the way. We've clearly seen that with heifer pregnancy or pregnancy-like traits, especially in dairy. Everybody's probably familiar with the very selection on milk production for a long period of time, seeing the decline in fertility rates. We're
Yeah.
actually seeing that uptick now again because of selection on fertility. So
Okay.
I don't want to say those don't work. They do work, but we're trying to enhance how we can evaluate them to capture more of that genetic variability, make it more accurate, make it go faster. And so my idea is sort of with this, and I don't know if I'll quite get into my PhD, but I'm hoping to do it a little bit after, is to really figure out a way to find those underlying characteristics, if you will, like progesterone concentration, ovulation cycles, placental binding proteins, placental attachments, things like that. Identify which are important, and I kind of want to use some of our omics, if you will, which is kind of like our sequencing with RNA and proteomics, where we figure out the proteins and metabolomics. Kind of the hot topic in our industry as far as academia goes right now is how can we utilize these things.
Mm-hmm.
I want to utilize those things to identify these underlying traits that lead to conception. And I actually want to do genetic evaluations on those to determine if they're heritable.
Mm-hmm.
But I also want to take uh, AI, so artificial intelligence in this case, not artificial
Right.
insemination. So the other AI, it's always funny having to make that distinction. I always say artificial intelligence in other crowds of non-livestock producers because no one thinks artificial insemination when you're in the general public.
Right.
But
Yeah.
artificial intelligence in this case, I want to take that and figure out how those traits, those subtraits are interacting together to see if we can predict pregnancy or conception with reasonably high accuracy, and then find out which of those seem to be most important in their interactions to lead to that, and then try to also gauge at what threshold do you kind of get minimal response back from that, if you will. Like,
Yeah.
at some point, do you need more progesterone, or could progesterone even become harmful to some point afterwards?
Oh, okay.
So kind of finding what we call what this intermediate optimum is, if you will. And then I want to use that as a selection threshold for these underlying traits. So we did genetic evaluation. We've seen kind of what that threshold we now need is to achieve optimal conception rates. Put that all together into some type of index to make it easy, or some type of other system that allows for selection on a singular value to move all those subtraits towards their ideal targets or those ideal intermediate optimums and try to maintain them there to maximize conception rates. And I think that might lead us to a little bit quicker genetic progress in trying to evaluate this overarching trait of heifer pregnancy or sire conception rate that just our models aren't really built to account or to accommodate sort of the underlying architecture that's kind of like they don't capture it very well because they weren't made to model it.
I see.
It's what I would call a multiplicative model. Like I said, remember, if one of these things fail, multiply by zero. It does not happen. But
Mm-hmm.
we have what's called a linear model. And that linear model is very good for capturing straight lines of relationships. But when you have multiplied by 0 and 1, you tend to get these weird shapes that have curves all over them. And so
Okay.
that's why I think a big part, that and the data centering are a big part why I don't think our models are doing a very good job of capturing this genetic variation. Now, again, we still can make genetic progress. We do make genetic progress. They work.
Mm-hmm.
But what I want to do is get at the underlying biology, find a way to make it easy to tackle, and use that to predict conception rate phenotypically with more bigger models like artificial intelligence that can accommodate that nonlinearity pretty well,
Mm-hmm.
and therefore speed up our genetic evaluation by selecting on the underlying pieces to move towards those targets.
It sounds like that the goal in terms is to maybe like refine the measuring stick a little bit better.
That is a good way of putting it. Yeah.
All right. I thought that I'm hoping I was going to say, I wanted to say that and I don't want to sound like an idiot and then miss the whole point. But particularly there at the end, you said that it wasn't measuring because I just feel like the measuring stick is, you're working on altering the measuring stick to measure more things in a better fashion. So that's very important.
And that's a great way of putting it. Yeah. Our current measuring stick does not do the best job at measuring. It's not the most precise. How can we be more precise? And that way we can enhance the rate of genetic progress we make. And as probably all producers know, our most important traits tend to be our least heritable. So, fertility and pregnancy, cow longevity, things along those lines. Those cost the most amount of money for us to,
Yeah,
if they fail, right? I mean, this is expensive to raise a female. It's expensive if a cow doesn't have a calf, we're not making any money, period.
absolutely. Yeah.
So they tend to be what's called the most lowly heritable, but also the most economically important. But these things are also, if we think about something like longevity or disease status, right? If an animal dies, it's same thing, no money, right? But we've lost money.
Yeah.
But all these things we typically measure in a binary 0-1, like pregnant, not pregnant, died,
Mm-hmm.
not died, or
Yeah.
longevity. It's like we have 5 to 7 years, something like that along those lines. It's basically a category rather than an actual number, like 215.62 pounds, right?
Yeah.
That'd be much more of a numeric measurement we do. And I think it's a big part of the reason why we see these models not working as well, because they work, just not as well for these categorical traits. Is there the underlying biology of these things is we're trying to capture this thing, but really things like longevity and pregnancy are very complicated processes. They involve a lot of things happen biologically, and it just turns out that it's not what we call that nonlinear process, if you will. At least in my mind, that's my hypothesis. I should say I don't know that for a fact. That's my hypothesis. It's that nonlinear process, and so the models can only capture so much of that when they're not built to handle that.
Mm-hmm.
And so that's why they work really well for our other traits like weaning weight that tend to have a more linear outcome from the underlying biology compared to these more categorical multiply by 0, multiplied by 1 to get your 0-1 outcomes.
Mm-hmm.
So basically the whole goal here is how can we start building a system or a framework to handle the actual trait complexity a little better, if you will, and therefore we can actually start making really much more quick progress rather than the slower progress we're making today.
You're talking about economically relevant traits, and like that research is going to have outcomes that producers can get their hands on and like implement and see actual tangible impacts. And that's so important for research outcomes to actually become tangible and usable at the producer level.
Yeah, and hopefully the goal is, you can make fertility progress, but we want to make sure it doesn't take 20 years to make fertility progress.
Right, exactly. Yeah, that's super important.
It's time for our famous three.
Well, we've reached a point of our episode where I ask the same questions of every guest. So we're transitioning from the quote unquote the meat of the episode more to like the dessert here. So I gave you a heads up on these questions earlier, and so we asked them of every guest. And the first one is, what is your favorite beef or cattle related book or resource? It can be a website, it can be a genetics manual. I have had a guest who gave the example of his wife was his favorite beef cattle resource because she manages like the genetics and things, and he manages like marketing and data and other things like that. So that was a great answer. So what is your favorite beef or cattle related book or resource?
You know what? I'm actually probably going to give a pretty similar answer in the sense that as an academic, I am always engrossed in academia. A lot of my friends I talk to on a daily basis are also from similar type of. They were did their masters with me, for example, and we're always hypothesizing things, talking about modeling nuances or statistics or things along those lines. It can be pretty easy to get a little disconnected from the industry at times if you're not, staying connected to the industry.
Yeah.
So I'd actually have to say one of my favorite resources is actually my parents, and then publications like Drovers and other things are
Oh, great.
they help keep me grounded with real life issues that are occurring in the industry that I'm not a part of on a daily basis anymore because I only go home so often, on a grad student stipend driving 4 hours in a truck each way, but
Right. Yes.
not too far away. This gas gets a little expensive, especially in the summers. But I really like my parents and those publications and other producers as well because they keep me grounded. They keep me current with relevant issues in industry, but they also teach me how is the producer thinking about this? Where are the disconnects and challenges that lie, or what's the current beliefs? And that oftentimes guides how I approach a topic or how I talk to producers about certain things because if I can't make it relevant to the producers, then I can't do my job basically. So I have to make so keeping grounded with producers is probably my most important resource by actually talking to them.
I love that answer. And it's interesting because just yesterday or maybe the day before I interviewed a guest, and she said that like a lot of the basis for research that she does comes from questions that she gets in her extension work. And so I just found that interesting because that's similar to what you're saying is like, is your research, how it's going to affect people? And you're using drovers
Mm-hmm.
and your parents to figure out like the needs that they have and their concerns and things like that. So it's a similar but different type thing. So I love that. And I love it whenever the answer is another person. I think that's a lot of fun. So
Yeah, another great one, Beef Improvement Federation annual meeting.
there you
That's a
go.
great meeting that has a lot of it has kind of a mix of everybody. It has your industry, like your breed associations, and um, some of your semen companies and some of your genetics companies there. It has your academics, of course, but it also has your producers,
Mm-hmm.
and in this case, I'd say more some of our larger producers there. But it's actually a great time to reconnect with a lot of people and talk to them. And like I said, it keeps you grounded when you talk to people from that as actually A, utilizing what you're trying to put out, but then B, also has a completely different whole life perspective than you versus if you're just in academia, it's really easy to be, oh, I think this is a really interesting topic,
Mm-hmm.
but what's the usability of that? Because we're definitely in a very applied, very industry centric type of research position here. What we do compared to someone who does more basic sciences.
Right.
So I
Yes.
think it's always an important aspect for anybody in animal science research is to be grounded by keeping in contact with their customer base more, or I guess their representative base, if you will, which is the producers.
No, I completely agree with that. And will uh, second what you said about the BIF conference. That is a really great conference, and I encourage anyone who is listening to go to attend that and the symposium and things like that. So that's great.
Tennessee this year,
Oh, it is in Tennessee. It was
Knoxville, Tennessee.
in Canada last year, which was nice because it was in July. So that's where you want to be in July is in Canada, not in Tennessee. So or Texas or something like that.
Oh,
So
I'm trying to remember. I need to go back and look at the dates. I can't remember if it's in June or July this year. I don't remember off the top of my head, but
June might be better.
definitely everybody interested, check it out. Go look it up. Knoxville, Tennessee.
Yeah.
Um, Troy Rowan, who's actually a fellow past Charolais breeder myself, is at the university there, and he's helping host and put it on this year. So I think it'll be pretty good because he seems pretty excited for it. And he's been implementing a lot of new things, especially for graduate students and I'm sure other people as well that I just haven't kept up with as much because I'm a little busy at the PhD right now. But
Right.
I think it'll be a pretty good conference, and it's definitely worth checking out if you're close to the area.
Yes, I encourage yeah, I echo what you're saying. Okay, so the second question is what is a book not related to the beef industry that you are currently reading or is one of your favorites?
That one, I will admit, when you said that, I was like, man, I'm not even sure I'm going to say this answer. This is kind of a struggle, and I will admit this is still a struggle. I would have to say I haven't really done a lot of personal reading too much outside of grad school in the last year. It's been a little busy. Um, I would say pretty much anything that's for personal pleasure that keeps me more or less sane, if you will. I'm not gonna sugarcoat it. A PhD, grad school is not an easy process in the best
No,
of times, and we've certainly had our fair share of unique challenges, I'd say, in the last 5 years with the pandemic and inflation, and of course, grad student stipends don't really change with inflation either. So,
right?
ev-
Yeah.
we're all trying to navigate around all those things happening in the job market, of course. So, pretty much anything that takes my mind off school and off kind of having to deal with kind of the day to day life and just lets me relax a little bit and keeps me sane, if you will. I think that's how I put it. So anything that's for fun reading.
Well, can you remember the last fun reading book you read?
I should because it was just a couple months ago and I don't really off the top of my head now.
Okay.
Let's see here. I did reread my favorite series from a kid, and it's called The Inheritance Cycle.
Oh, okay.
Aragon Ellis Bersinger Inheritance, and that one's that was kind of my favorite book series as a kid growing up. So I actually reread that, but that's completely like a more non-fictional kind of pseudo fantasy kind of medieval type setting. So very very much removed from from academia in the current world, if you will.
But that's okay. It's pleasure reading. It takes your mind off of the stresses of your life. And that's what the power of books and reading. So
Yeah, very similar to Lord of the Rings and like the construction of it, if you will. Maybe not quite as in depth on the world building as Tolkien's work, but very similar in the type of genre you're getting there.
great. That's very interesting. All right. Our last kind of rapid fire question is, when you think of someone that you look up to or admire, what is a trait that has enabled them to be successful? And you don't have to tell us who the person is, if you don't want to.
And I'd say there's a lot of people, to be honest, but the people I most look up to, and because again, there's a lot of people I look up to, and I think they all kind of share these. Many of them share these traits. One, just staying kind. I know
Mhm.
that sounds very not kind of what you'd expect, but I think at the end of the day, the most progress happens when people are just being kind, helpful, and working with each other and creating that really good atmosphere. I think that's when the most progress happens, and when people can really delve into what they want to do, rather than really just if you're working, if you're with people who don't like what they do and they don't want to be there, that kind of influences your mood too, and you're not as likely to do as well. So the people I admire the most tend to be very kind, very helpful, people who want to collaborate and work together. They also tend to be very driven and have a very specific interest, of course. Uh, and that's in this case, I'm going with the research scientist. I'm
Yeah. Yeah.
very used to seeing there. But I met a lot of scientists who encompass both. They're very kind, helpful people, and they're doesn't matter if you're a brand new grad student or a seasoned veteran who's having an intense theoretical discussion. They like to have conversations with everybody, and I think that's amazing for training the next round of graduate students or next set of professionals is really encouraging and being kind to those who are working their way up. And I try to implement that myself when talking to new graduate students, like and giving them that grace. It's like, hey, this isn't an overnight thing. I don't think I even knew what I was doing. It took me 3 years out of the 7 years I've been doing to even just begin to understand what I'm doing and start
Uh-huh.
making progress. And from there, you just sort of take off. But there's we are in 2024, and I'm sure everybody can appreciate just how much research alone has been done the last 10 or 20 years, let alone the last 70 or so since we've discovered DNA. And then if you go back even further, all the statistical framework that's been developed, there's a lot of knowledge that we have today. And so just giving everybody that little bit of grace and being kind to them, realizing find your unique blend of all the skills you need to build and knowledge you need to obtain, but uh, just be kind to yourself because it's a long process, takes a long time. It gets harder every year. We accumulate more and more knowledge. So I strive to be that person too.
Yeah. That's really important. Like you said, the be kind to others, because there's a cliche thing that says, it costs $0 to be kind to people. And that's absolutely true. But you also said there at the end, be kind to yourself. And I think that's really important, is that we can get really hard on ourselves and compare ourselves to other people. And being kind to yourself is just so, so important, regardless of what area of, your career is, whatever your background is. Just being kind to ourselves is really, really important. So I'm glad that you mentioned that.
Yeah, grad school especially, I think it's really easy because we tend to be pretty driven people who want to be the best at everything, and you as you grow up, you realize that's obviously not possible, right? And then,
Right.
but sometimes we tend to be our own harshest critics, or you
Yes.
get imposter syndrome, like you said, comparing yourself to, wow, look at like the Dr. Tallmans of the field and everybody else who
Yeah.
just genius is just sprouting forth from them every second of the day. And you're like, I'm over here, like, I feel like I'm taking a little hammer, just beating on beating on a toy block or something, more or less. But give it time. They've also had countless decades to perfect their craft and build their knowledge base and experience everything as it's happening. You're trying to cram all of that now in just a handful of years and learn it all. It takes time. It takes time.
Yeah.
Even after you learn it, it takes time to digest it all and build it in place and put in that framework to make use of it. So
Mm-hmm.
I think for grad students especially, and I think for anybody that's important. I know my experience at grad school, I know is that's especially important. Like you said, be kind to yourself. Imposter syndrome's a real thing. It'll come in time.
There's a whole lot of fake it till you make it going on that's been going on in my life for a really long time.
Absolutely.
So yeah, that's really important. I'm glad that you brought that up and elaborated on that. So, well, that is all the time that we have for today. That's the end of my questions. Thank you so much for joining us here on the show and talking to us about G/E interactions and all things genetics. And we literally got dug down into the data. And I really enjoyed this discussion and learned a lot from this discussion. So thank you for sharing that with us. If people want to learn more information about you or your research or follow you, maybe you're on LinkedIn or Twitter or something like that, this is your opportunity to kind of provide that plug.
So yeah, I do have a LinkedIn account. I technically have a Twitter account, but I'll be honest, probably don't use it too much. It's my social media. I'm probably not the best at posting my work stuff. I've actually started posting more of the fun stuff. I picked up rowing and snowboarding as hobbies, which are great expensive things to pick up as a grad student on a grad student budget. I'm sure you can imagine, but
I can, yes,
but you can follow me on LinkedIn. I'll hopefully we have some publications coming up pretty soon. I'll hopefully be posting them there, of course. And really, I think the best thing you can do is just email me. Honestly, I know I'm opening myself up to a whole can of worms there, but
That's okay.
I love actually just interacting with people. I'm not a big social media kind of guy. The online presence, like I can certainly, if people want to message me on social media too, I'd be more than happy to answer questions. But I'm not probably the best about posting huge insights on social media. I like conversations with people more than anything else. So reaching out to me directly, I think, is probably the best thing you can do. Either through Facebook, Instagram, LinkedIn, whatever it is, or email even.
So for anybody who would like to talk to Will more about research or grad school, to commiserate about grad school together. Again, Will, thank you so much for joining us. It was a pleasure to meet you and to learn more about genetics from you and G/E interactions. And I have to say, go Wildcats. And so to our audience, thank you for joining us on the show. We hope that you'll join us next week as we come back here on the Beef Podcast.
Absolutely. Thank you for having me. I really enjoyed it. And go Wildcats, but also go Pokes.
Oh my gosh, I have to end it there. We're done now.